Alright, so Common Core Algebra 1, here we go for the next chapter, which is going to be about systems of inequalities. So very similar to the last chapter when we talked about systems of equations. We're only going to have 2 lessons for this one. The first one is going to be graphing the linear inequality when we talk in slope intercept form, which you see right here we've had before, and then graphing a system of linear inequalities. And they're very similar, and they're also very similar to when we graphed a system of linear equations. Okay, so first off, just to remind ourselves how to graph a system of, or how to graph inequalities, we're going to look at this first equation, y equals x minus 2, and I'm going to do that one in red. So I put a point, and I don't want to put a point there. I want to put a point at negative 2 in red. And then my slope is negative 1 over positive 1, so I'm going to go down 1, right 1, and remember I can do that as many times as I want. I could even do the opposite, up 1, left 1, as many times as I want. And then I'll graph my line. And something to keep in mind here too, I want to do a dotted line, or dashed line, because we are not including the line. And we don't include the line, remember, because we have just less than here. Okay, the next one then I'm going to do in black. I need to start at 6. Actually, whoops, before we do that, we want to shade this other one. So we do our test point 0, 0. So I plug in 0 and 0 minus 2. This says 0 is greater than negative 2, which remember is a true statement. So that tells me to shade everything that's on the same side. That test point was right here. So I'm going to shade everything up and to the right. Alright, the next one I'm going to do then is this. So I put a point at positive 6, and then my slope is 3 over 1, so I go up 3, right 1. I could do the opposite as well, down 3, left 1, and I can do that as many times as I want. So I'll do that, and then I'll graph my line. In this case, remember, our line needs to stay solid because we are including. We've got that symbol right there, so that tells us to stay solid. Okay, so I'm going to draw my line through there, and then I can make that a little bit more accurate. So I'll do that. There we go. And then I need to choose shade here. So I'm going to again test my point. 3 times 0 plus 6, that's going to be 0 plus 6 is 6, which is again a true statement. So this point is true. So everything down here is true. Okay, and that'll give us how to, we graphed 2 different inequalities there. So one in red, one in black. A system of linear inequalities then is going to be 2 or more inequalities with the same variables. Pretty much the same definition as a system of linear equations, except for now we talk about inequalities. Our solution is going to be an infinite amount of points shown on the graph by shading. And remember, a solution, same idea, is one that makes your inequality a true statement. And to check that, we just take that point and plug in or substitute the x, y values to test to see if the inequalities are true. And if it is true, then they are a solution. If it's false, it is not a solution. So checking the 2 points here, let's do 2 examples. So I'm going to do one over here on the left, 8, 3. And remember, you need to check it in both inequalities. So I plug in 3 for y. Whoops. And I get 3 less than 8 minus 4. And if I do 8 minus 4, I get 4. So first one is true. Okay, we're good so far. If I check in the other one, plugging 3 in for y and 8 in for x, I get 3 is greater than or equal to negative 8 plus 3. And if I do negative 8 plus 3, I get negative 5. And that is also true. So we can say that yes, 8, 3 is a solution because it made both inequalities a true statement. 3 is less than 4 and 3 is greater than negative 5. If I check my other one then, so I plug in 2 for y, 0 for x, and this will show that 2 is less than, this gives us a negative 4, which is not true. So we could say no, 0, 2 is not a solution. Okay, so to graph or solving a system of inequalities, what we're going to do is you're going to start by graphing each inequality. Okay, and then we're going to look, and we're going to need to use a test point, and a lot of times we're going to need to use several test points. It could be up 2, 4 to find a solution to each inequality. And what we're going to do then is look and say, where do our two shadings intersect? And we want to shade where they are both true statements. Okay. Just like when we talked about systems of equations, there can be times that they never overlap with shading, which means it would be an inconsistent system and we'll have no solutions. There will be times when they overlap everywhere, in which case it's called a dependent system, and they are solvable everywhere. So let's do our first one in red. I'm going to put plus 7 up here, and then I'm going to go up 2 and right 1. And then I'm going to do the same thing. I'm actually going to come down 2 and left 1 just like we could. I'm going to do that a couple times, and then I'll graph my line in red. And I want to make sure that this is a dotted line again because we're not including the value here. So up 2, right 1, I'm going to graph that line, and let's try to make that a little more accurate. There we go. And my second one, we will do that one in blue. So I'm going to put a negative, point at -1, and I can go down 2, right 1, down 2, right 1, and then I can also go up 2, left 1, up 2, left 1, and same idea. I'm going to graph this one in blue and make sure again that I have a dotted line because we don't include. And so then I'm going to draw my line through there. Okay, other thing, I'm going to make sure I make this extra long like that. So you notice that if we look at this, we actually have 4 regions here. Okay, we've got the bottom one here bounded by both those lines, to the right, the top, and to the left. Now what may be easiest to decide which point to shade, or which one of these 4 regions to shade, is to take a test point in each region. So the first one is 0, 0. That's our easiest one to test. If I plug that in, I get 0 is less than, this would be 0 plus 7 is 7. And if I plug in the second one, 0 is greater than, that would be 0 minus 1. So 0 is less than 7, 0 is greater than -1, which we got lucky on this one. We only have to shade the first region we tested, just that first one. Okay, what it would look like if it did not work here, I could test another point. So let's just pick some random point I could put right there. Okay, this point has coordinates -2, 9. So I'd plug in 9 for y and -2 for x, and I test that. So I'd see 9 is less than, this would be -4 plus 7. So 9 is less than 3, which we know is not true. So we definitely don't want to shade this region because it doesn't work. Okay, I could do the same thing. I could pick some other point over here and throw that in and test it for both. It wouldn't work for one. I could throw over here, grab some random point, throw it in, test it. It would not work for one. So since it doesn't work for any of these 3 points, and it did work for 0, 0, we want to make sure we shade the side where 0, 0 is. Okay, we're never going to shade more than 1 region when we have like this. Okay, the most we could see is 4 regions. We'll never shade more than 1. So we're going to skip that. That is it for graphing a system of linear inequalities. When we do our next lesson, it's going to be the same general principle, except for we're not going to look at slope-intercept this time. We'll look at reminding ourselves how to graph with x and y intercepts again. Okay, we'll see you next time.